Ladies and gentlemen, welcome back to another live stream. So in this live stream, we're going to be creating an asynchronous LLM chat using iced and rig Rust library. Okay, so let's get started. Obviously, it's going to be like provider, AI provider agnostic, meaning you could use it with Llama, OpenAI API key, or Claude, or Gemini. Doesn't really matter. It supports all of those. In this video, though, we're going to be using Llama, pretty much for local testing. It's pretty much we're just going to be I have an RTX 3050. Which have like 6 GB of VRAM, so I could run comfortably like some 7B model, I think. I mean, let me check that out. Hold on. Yeah, so I have Dolphin Mistral, which is the most like unrestricted model, Llama model. And there's also Phi 3, which is the sweet spot, the middle sweet spot for my current GPU. Anyways, let me share the stream in my Discord. You can join my Discord server. You can find the link down in the description below. Live. Okay. And let's just get started already at this point. Let's pop out the chat really quickly. And let's go. Okay. So let's start a new project. And we're going to call this project... is the stream fine? I mean... yeah, seems fine to me. Alright, so let's just get started anyways. So I'm gonna call this, I guess, Cohere LLM or something, or like LLM chat. Okay, fine. And let's make it a binary. Now I thought about creating a backend, like using Axum or something, but that's too much for a live stream. So I'll just start simple for now with just iced. Okay, so let's get started. Alright, so we got here version, so latest version. Hello, Theo Paris, welcome to the live stream. We're not going to be using any default features. We're going to do our own features. So we're going to be using Tokyo for the runtime of iced. And we're going to be using Wayland, obviously, because if you also want to support X11, then also include X11 here, but I don't really care about that. And here we also need to add Linux theme detection for detecting the theme. So you would automatically get dark theme or light theme in your Linux system. Next up, let's also choose, actually let's choose that even before Wayland or anything. You could also choose the renderer. There's like WGPU and WGPU Bear. And there's also Tiny Skia, which is much smaller and doesn't even need the GPU to run. So let's go with Tiny Skia because it's going to be way faster to compile, honestly. Next up, what we're going to need next. I'm not sure if we need to add Tokyo manually because like iced already handle that business for us, I think. No, probably we still need to add it manually, so fine. Tokyo, and let's add a version. Default features false. I think there is no default features enabled, but just in case, I guess, fine. And the features would go with, well, for now we're gonna need just like RT multi-thread. Yeah. We don't even need the macros because like the Tokyo runtime is being made for us and ran through iced. So we're good there. Next up we have a choice, a fork-in-the-road. We either use a rig-core. So rig basically handles all the LLM tools and like requests and streaming for us. It basically uses request under the hood and it writes the JSON, etc. And hello NZ, welcome to live stream. Okay, but rig, so yeah, that's what rig does. Or you could just go straight up raw and just make everything yourself using request directly, which would give you more control. But then you're going to be writing a lot of the boilerplate code that is already given to you by rig core. The other nice thing about rig is that it's provider agnostic, meaning you could use it with any LLM you want, which is pretty sick. And it gives a pretty like, what can I say? Rust idiomatic interface, so you don't have to deal with JSON stuff and like read the LLM specs and so on. Anyways, and like deal with errors, etc. Whatever. So let's just go with rig core here. There's even some other rig libraries that you could also include for several integrations too, which is nice because like rig is using traits for everything, so you could like literally implement traits for anything you want. Like let's say you want to integrate something that rig doesn't know about, that you could easily basically do that. Like let's say, for example, if you want to include fast embed, which is used for like local embeddings, which we're going to talk about later on maybe. You could include rig-fast embed, Gemini gRPC, Helix DB, Lens DB, Mulvis, MongoDB, Neo4j, you name it, you know. So anything you want. There's probably already a crate for it to help in rig, as you can see. Rig's QLite, S3 vectors, Qdrant. Qdrant is pretty much the most popular, I think, and the most performant vector database. But for now, we only need the rig core, so let's go with that. Version, and I think we could probably go with default features false, and let's see what features we have here. So you may need Derive for using any Derive stuff. There's even Discord bot, audio. It also supports, by the way, audio and video, which is pretty cool. And also even image, PDFs, and loading all sorts of like documents and such. So basically loaders. So that's cool. Next up, there's even Rayon, request, middleware, and RMCP. This is for, what is it called? MCP protocols, which is basically instead of you having to go ahead and like implement. So let's say you want the AI to be able to access the file system. Then what you do is you basically go ahead and like create a rig tool that is exposed to the AI yourself. And every time you want to add a new tool, you have to re-implement it yourself every single time, which sucks. So what you could do instead is you could use RMCP, which is basically Rust MCP integration. And then basically you could just run off any kind of tools in its own kind of like server. And then the AI could basically access it easily. So that's pretty cool. Oh, I didn't know rig was a thing until now. I'll have to consider for my LLM Discord bot. Yeah, it's pretty sick. It's pretty nice. I love that so far. Anyways, so for now, I think we don't need any of these features, isn't it? Yeah, I think maybe we don't need any of these features for now, so we're good. We'll see though how it goes. Other than that, yeah, that seems great. Anything else? I don't think so. Actually, we do need anyhow as always. And possibly you could also add tracing if you want for logging. Tracing and tracing subscriber. And yeah, that's pretty cool. Pretty cool. Next up. Alright, so let's just let this compile. And let's go. And let's see how much it would take, though take into account that I'm, you know, streaming and stuff, so it's gonna be a little slower than average. But yeah, and here I could actually start my Ollama model already, so I could just say serve, Ollama serve. And obviously before that I actually did something else. I don't remember what command I ran. I think I ran probably pull. So like you just basically first of all say sudo pacman-s Ollama, and if you and then after that, if you have like NVIDIA GPU, then also install Ollama CUDA, so it could basically use the GPU. Otherwise, it would only use the CPU. After that, you could just run Ollama. I think probably pull. So like Ollama pull. And whatever model you want. In my case, I'm using Phi 3. which takes around like 3 GB of VRAM, I think, which is the sweet spot for my GPU. Though if I wasn't streaming and stuff, then I could probably go with a more powerful model. But other than that, we're good. You could even sign in apparently, which is interesting. You could list the running models, copy models. It's kind of like, you know, what is it called? It's kind of like Docker and stuff. Anyways, so right now what I'm going to do, I'm just going to say serve, and then it would run Ollama local server. So I could basically use it for my, and as you can see, it's using my GPU right now. And if you even check like the task monitor here, or system monitor, I honestly, let me pin this because I need it a lot of times. Or did I already pin it? I don't know. Anyways, so if you come check here and look for Ollama, well, apparently it's not using any GPU memory yet because it haven't started yet. But at some point, when you start like use it for the first time, it's gonna load the whole thing into the GPU, and then you could use it. Anyways, so I guess let's get started already, and let's see what we could do. So we're gonna check the rig documentation here. So quick start guide, and let's see. So here, well, actually let's start off iced application first. Fine. So iced application, app new, app update, and app now I could go crazy with the architecture. I could even make a backend and such, but you know, let's keep things very simple, especially that I'm streaming and stuff, so we really want to move fast. So I'm just gonna go with one single file for literally everything. So yeah, app new, app update, and app view. So it's obviously using the LLM architecture, and we're gonna run the application, and that would return an iced result, which we could just return here. And that's basically it. Now let's just create a struct app. And we're also gonna need like a struct message, which definitely needs to derive clone, at the very least. And then we're just gonna implement app. So we're gonna have like a fnu, which would return self, and fn update, which basically it's kind of like a reducer, kind of like Redux, if you know that. So you just could take the state, which is the application here, and obviously by like mutable state, and then you take in a message of some sort, and it basically returns back a task. Well, actually it's a bit different from a reducer, because what a reducer usually does, though, I think it's probably you do this and then you just like return a new state to some degree. But yeah, let's not go there for now at least. So task, and here you give it the message of your application. Okay, next up you got the view. So the view, on the other hand, it's what makes the UI for you, and it only needs like a read-only reference to self. So it doesn't mutate any state directly, too simply. It just renders whatever state you have there. Next up, it would return an element, iced element, and you give it some lifetime here, and then your message here. So element is basically kind of like the interface, and obviously it should be, I think, impl. No, not really. So this is kind of like the interface of all the UI elements. So all the iced UI elements could be converted into an element essentially, as you're gonna see in a second. So we could go here and say column new dot into, and there we go. And here we could just say task none for now. Next up, here we got like self, so we're just gonna return self, and let's go. And that's pretty much all it takes to create your first iced application that does nothing. Okay, cool. So we got this out of the way. Next up, what we're gonna do, we're gonna make a client. So a client is basically, you say OpenAI client from environment, which basically would use like the environment variable, or you could use any other provider pretty much. If you go to here, model providers, I think, right or no? There is was a page where it lists all the model providers available. I wonder where is that. Our list of providers that there we go. So currently Rig supports all of these providers: Anthropic, OpenAI, Azure OpenAI, Cohere, DeepSeek, Eternal AI, Google Gemini, whatever, you name it. And let's say in our case we want to go with Ollama, which is the local model. So we're just going to open link in new tab. And there we go. So, and you're going to get some code right here. So you basically just say Ollama client new. So basically if it was OpenAI, I would say here OpenAI instead. Client new. And in our case, since this is a local model, it doesn't need any API key. So we just give it nothing. If this was OpenAI or something else, here we usually either give it the API key or say from NV, so we can use the environment variable. So, and then you just create some agents, right? So using that client, and in our case, you select the model. In this case, it's Qwen 2.5. And then you could give it even a preamble. Obviously, this is optional. And so in this case, it's you are a comedian here to entertain the user using the humor and jokes. And then you build the agent. Now, I think probably building an agent is pretty cheap, I would guess. But yeah, don't take my word for that. Now prompt the agent and print response. And then you just say .prompt. And there's also some other stuff. Now the problem with this prompt function, so you do give it the prompt here, entertain me, and then you just await and obviously enwrap the error. But the problem with this is that it's a one shot. So your application would just freeze until you get a full response from the LLM, which could take a lot of time. So on the other hand, there is something called streaming. Here we go. It's kind of when you're using a regular LLM, it actually streams token by token into your chat. And this is how you do it. You use the streaming interface. So instead of prompt, you say stream prompt. Tell me a story, await, and then you basically keep on so a stream is basically an async iterator in Rust, and then you just keep on saying stream.next.await, and then you basically get the next chunk or the next token. So the next token could be either text or tool call delta or final usage. So text, well, obviously it's text. Tool call have to do with tool calls, obviously. And the final usage, basically once your prompt response is done, Rig gives you back the how much tokens you have used, etc., and other statistics essentially. And yeah, it also actually gives you the final response too, but we'll see about that in a second. There's also another one called stream chat, which we're actually going to be using today, which you basically give it the prompt and then the chat history, which is just a vector of messages. And then it basically takes care of that. So essentially prompts, it's one shot. So the LLM doesn't have any context of or a history of your previous messages. It's just one prompt, one response. On the other hand, stream chat, it basically sends the whole history of your chat to the LLM, so it can keep track of the whole conversation. Next up, we got, now obviously there's probably even more advanced ways to do this, using embeddings and all sorts of things, but let's not go there for now. Other than that, you could also apparently low-level streaming interface with full request custom. Okay, so basically if you want some customizations like changing the temperature of the model or the agent or whatever, then you basically just say stream completion, you give it the prompt, the chat history, and then here you could use the builder to set the properties like temperature, etc. And yeah, I think that's probably all I wanted to explore here for now. And also, if you just want to stream directly into std out instead of a UI or something, then you could just use stream to std out directly, and then it would just work. There's also pause control and stuff. But yeah, all right, so let's actually get started already. So let's create a client first. So we're gonna use Ollama client. There you go. And as you can see, there is new on even from NV apparently. But let's just say new, and we're gonna pass in nothing here, no API key. And here this gives me back a result. So as you can see, it returns a client LlamaExt generic, because essentially the client is apparently like generic upon which model you're using essentially. And also, what else? Even the request client, I'm not sure what's that, but yeah. Now as you can see, you have the HTTP, oh yeah, the request client. So you could give it like a custom request client, and even headers, base URL, and finally ext. Oh well, anyways, let's just get going right now. Let's just unwrap this. Now that we got the client, let's create an agent. So agent is client.agent. Wait, what? Client.agent. Well, that's strange, but let's see what we're gonna use. We're gonna use phi3. Yeah, let's use phi3 in this case. I mean, we could make it customizable so the user could like choose which agent they want, but let's not go there for now. And okay, why this is not working? Because we need to import something. Now let's just go with the completion client rig prelude, or let's just like import the whole prelude pretty much of rig. And we're good to go. So basically, to be able to use this agent, you got to make sure to like import that completion model trait, because there's multiple traits. There's like a completion model agent, and there's even embedding model agent. Other than that, what else we could do here? Now we could just build, and we could even give it a preamble, name, additional params, context. Yeah. Dynamic context, so we could give it like documents and stuff like that. Dynamic tools, so there's basically static tools and dynamic tools. Static tools, essentially it's some tools that are passed with every request to the LLM you make, so it could be quite expensive. On the other hand, dynamic tools, it just basically the AI or the LLM use them whenever it needs to, whenever it looks for it, essentially. It's probably needs like, yeah, it does need a vector database or something like that. Other than that, you could also set the max tokens, output schema, temperature, and stuff like that. Anyways, so now I think we could just pretty much just build the agent, and there we go. Now we have our agent. We could just store it right now. And here it's basically agent and completion model. Now completion model depends on the provider. So rig providers, Ollama, what is it? Completion model, there you go. But you could probably make this generic on any LLM model if you use maybe Box or something, but let's not go there for now, we're fine. And yeah, so that's how you create an agent. Next step, what we do. Next step, we could, I mean, let's try to make some response really quickly. So let's try to prompt something. Agent.prompt. So prompt, and then you give it some string. Let's say, hello, can you write a Rust program? And then we could basically just await this and let response. And let's just unwrap the result. And obviously to run the await thing, we could use Tokyo here. So Tokyo spawn, async move, I think. There you go. So we could just spawn a Tokyo task there and just run this. And we could just go ahead and like print the response. And there you go. Now apparently the agent got moved, so we probably need to like clone it. So agent.clone, I think, yeah. And then what? Let's just use agent 2 here. And let's go. All right, so let's see what's gonna output. Okay, so it's gonna take a little bit of time, and there we go. So as you can see, it actually answered. Certainly, here's a simple Rust hello world example. Rust fn main print line hello world. This is your basic starting point in writing programs, blah, blah. But as you can see, it takes time to actually get a response. So what I could do instead is stream prompt. There you go, import. And apparently I don't need in wrap. And now instead of, so I basically get a stream back. Now instead of doing this, I could say, what is that called again? I forgot. Streaming IO. There you go, stream to SCD ouch. And then you basically just give it the stream here. And you're good to go. So this is our stream in this case. And let's just await this and in-wrap the results. Let's make this mutable. And let's go. Now if we run this, you can see that the tokens is being like, you know, streamed into my console right now asynchronously. So as you can see, my app is still, you know, very interactive. But yeah, so that's how it works. Other than that, you could also obviously say while let blah blah blah. Anyways, so now that we see how this actually works, let's start by making some UI for this to work, okay? And also another thing, by the way, we're gonna use later is in Iced, which is gonna be, so like Iced have a markdown viewer, so it could actually parse markdown, which is pretty cool. And it even have syntax highlighting. Highlighter, so there's a highlighter and iced highlighter. I'm not sure what's the difference between them. I have not tried highlighters yet, so I guess we'll just keep that for now. Other than that, there's also zipper, which is very interesting for asynchronous streams. Yeah, now let me just check out on that highlighter really quickly though. So if we go to Rust Iced, GitHub, and we check the tags, and let's make sure we select the right version that we're using. In my case, I'm using version 0.14.0, and let's go to the examples maybe. And let's check for some syntax highlighter or something. There you go. Cargo toml. So as you can see, it's using Syntax, which is another Rust library for syntax highlighting, which is like a standalone library though. Though I don't think you have to be that hard. Yeah, I mean, I tried it like a long time ago, at least the highlighting. It wasn't really this complex. But we'll just avoid the highlighting, I think, for now. We'll only keep the markdown though. So markdown. Where's markdown? Examples. Markdown. There you go. Oh, actually, did I? Wait. Let's check highlighter again. Or, yeah, highlighter. Did I miss something here? No, I didn't. Okay, whichever. Let's just go with the markdown example. And let's see. So cargo toml. And we also need Tokyo features fs if you want to go with file system, but nah, request features. Okay, there you go. Iced features, markdown, highlighter, image, Tokyo, and debug. Okay. So if you want to support images too, then we also got to add that. So image, and there's even image without codecs. I think maybe image without codecs probably is like using maybe the OS to encode and decode images, possibly. Any key reasons behind using Iced as opposed to Diaxis or Water UI? I love Iced Elm architecture, which is basically every update is done in one single place. So like any state mutation is done in the update function, and like the UI is like not mutable essentially. So like it just get a read-only reference to self, and also the fact that it's pure Rust, so no weird macros or anything, and it doesn't use any HTML, CSS, or whatever. So it's just pure Rust. You just write the layout or like the UI every single time. You rebuild the layout every time the frame get changed, and you're done there. And basically ICE takes care of mutating the stuff that have changed for you. So that's cool. Yeah, I don't like the HTML macros. Honestly, all macros, I don't like them because they break the tools, like the formatter and stuff. So I don't use them. In fact, like ICE, for example, even have like some other macros, like let's say column and stuff, but I don't use it either. I just use column.new. And the other nice thing about this, instead of using macros, is that if you use the macros every single time you create like some sort of like an element here inside of the column, you have to convert it into elements by using .into. So you end up with say .int a, .into, comma b, .into, etc. But if you use the builder way of doing it, using just column.new, .push, you don't have to actually convert it into elements, because it takes whatever implements into element itself, and it basically does that for you automatically. So you just end up with push a, push b, instead of push a into, push b into, etc. So like the into is done for you by the function itself, if you notice here. As you can see, child.into. And yeah, so that's pretty much it. If there's any other questions, please let me know. All right, so other than that, where we were, let's see. Okay, so we were looking into this example, and we wanted to add the markdown, the highlighted image, and Tokyo. There's even a debug feature, but I haven't honestly tried that yet. Did I add the highlighter? I didn't. I'm not sure what iced highlighter is for, but anyways. Other than that, what else? Yeah, I think we're good for now. Yeah, I think we're good for now. Let's just go to src, I think, and main, and let's check how this works. As you can see, it just have like some markdown content, text editor content. Oh, text editor. Oh yeah, there is like a widget text editor, I think. Yeah, there is. So that's cool. But I don't think we could use that for editing prompts and such, like editing messages. Yeah. All right, we'll see. We'll see. Other than that, what else? So here, just like including the overview.md into the binary, and then here it's like parsing the markdown, so the string. And what else? Yeah, that's pretty much it. Anyways, let's just go into business right now and let's see what we could do. Is there, like, by the way, an example for zipper? Or do I have to try to figure out how to use that again? Because zipper is pretty interesting. Now, what you usually do for creating an async stream is that you would create your own channel and stuff, but zipper actually handles that for you. It just gives you a channel that you could use directly. In fact, let me show you, like Rust zipper. So a zipper is a type-safe feature that can stream progress. Effectively, a zipper combines a feature and a stream together to represent an asynchronous task that produces some output and notifies of some progress. So basically, a stream only kind of like an iterator. It just gives up one item at a time, nothing else. But on the other hand, a zipper actually have two kinds of types. You have the progress type, which is basically what you get while the stream is progressing, and you got the output type, which is like the final output. So what you could basically do, for example, is that you would stream, let's say, the progress in fractions, and then finally would output the final output, like the file that got downloaded or whatever. In fact, a zipper implements both the future and stream traits, which gives you all the great combinators from future XT and stream XT for free. Generally, zipper should be chosen over stream when the final value produced at the end of the task is important and inherently different from the other values. But yeah. As you can see, download, running, progress, and done file. But yeah. Other than that, I think let's just get going, I believe. All right, fine. Okay, so what we're gonna do now? So let's create a UI already. Let's create a UI. So what we're gonna do is we're gonna push a scroll container because we want to be able to scroll, obviously. No, scrollable actually. It's called scrollable. Yeah. So scrollable new. And what we're gonna do here takes one per. Okay. So and it needs some content thing inside of it. So in our case, what should we try to use? Let's just go with a regular text widget for now. Regular text widget, yeah. And we're just gonna use like self.response. Actually, no, it's gonna be like respond or messages. Yeah, let's call that messages, I guess. And the messages would basically be, well, here we're gonna have some messages, which is basically gonna be like a vector of a message, but not any message though. We want rig message. Let's see what kind of, wait, so like if we say here agent dot chat, stream chat, what type that is? Message. So it's inside the completion message. Okay. So let's go ahead and use that. Rig completion message. And let's go. That's how it works. Sick. Next up, we're gonna say messages is basically a vec new, I think, right? Why this is, oh, there you go. Okay, I see. So what we're gonna do next is basically self.messages.fold, iter.fold, and we're gonna start off by a column, right? So column.new. And we're gonna push a few things here. Well, actually, nah. Let's just say column new, and here we're gonna get like the column and the current message essentially. And then we could basically like render that message by saying, okay. So for now, let's just use a text widget. Fine. So text widget, and we're gonna give it the message dot. Oh, how do you get the text out of this message? Okay, so apparently it's actually as you can see, an enum, one for the user message and one for the assistant message. So let's match on that. Match on message, and if it's a user message, well, not message though. This should be, honestly, you know what I'm gonna do? I'm gonna say use rig completion message as rig message, and then just use rig message here, and use rig message here and here, and there we go. Other than that, so this gives us the content, which is one or many user content. So one or many is basically just like either one element or a vector of elements. So basically when you only have one element, you avoid an allocation for no reason, but yeah. Other than that, I think we're good. And the assistant message containing one or more content types defined by assistant content. So the ID, option, string, and the content, assistant content. So the user content could either be text, tool, result, image, audio, video, or document. And the assistant content could either be a text, tool, call, reasoning, or image. In our case, we're just going to be handling, text. So yeah. So for now, I'm only going to bother with content. And what we're going to do next, we're just going to say text content dot. Well, actually, we got to match on the message again. So let's match on the content. And what the heck is this? Oh, I mean, it's one or many. So we gotta like go ahead and, yeah, like iterate through it. Gotcha. Gotcha. So let's go through it, I guess. For, what should we call this? Item, maybe, in content. And possibly the iter, right? Yeah, there you go. And what are we gonna do here? Oh, that's pretty interesting. I mean, we could use the same kind of trick again, in fact. Yeah, I mean, yeah, definitely. So let's just say content.iter.fold, column new again, comma, well, column, comma, item, or user content, fine. User content, and then we're just gonna say column.push, because basically the response could be multiple items of different types. Like you could have some text, then some image, then some audio or whichever, but you got the point either way. So column.push, and here we're just gonna create a text finally. But actually before that, again, we're gonna match on and see what kind of item this is. So match on the user content. And honestly, for the other ones, I'm just gonna ignore them for now. I'm just gonna say nothing. Or maybe we could even go with to do, or like unimplemented. Yeah, let's go with unimplemented. And here, I think the content or something, like the text. Okay, fine, let's call it text. And then we're just gonna say column.push iced with text, text.text. Honestly, that kind of sucked. Let's just call this content, fine. And anyways, cancel. And what else? So that was the user. Now the assistant, we basically do something similar. I don't care about duplicated code for now. Please don't annoy me. Next up, user content. Okay, assistant, user content, assistant content. And why this import? I guess rig message probably. There you go. And what else? Okay, add that, fine. Because we're kind of ignoring. I'm not sure what the ID is for, but we'll see about that, I guess. And we're not using the column here. Oh, wait a second, no. Ah, I see. I see. So how are we going to deal with this? I think we could call this fragment. And once we got the fragment, we could just push it out. So expected column message found. And then what we're gonna do is just like column.push fragment. Or you could just simply say this, in fact, even. There you go. And what's going on here? Consider cloning the value. Yeah, sure, I think. Or can we just maybe do this? Yeah, we could do that. Other than that, I think we're good. Yeah, just column.push. Content. And then here this. Now obviously this should go into its own function to be reusable, but for now we're just hard coding this kind of, not hard coding, but like, you know, just inlining this stuff for now. Other than that, what else? So we got all the messages and we're just gonna display them in a scrollable. Next up, we're gonna have like a box. Other than that, we also gotta make sure to have it like take the whole space that it can. So I'm gonna say height length fill. Wait, what kind of length it tried to use here? Because it does. Okay, no, not that length. Length. And we're gonna go with iced length and fill. We're gonna tell it to fill. And after the messages, we're gonna basically push. Well, obviously in the column, we're gonna push a text box. So text input. And for the text input, we're gonna go with a placeholder, which is basically ask anything. And then the value, which is going to be our self.prompt reference, obviously. And yeah, so our app would also store a prompt. So prompt string. And I think we're good now. So just add the missing fields, and this is basically string new. And let's go. Now what we're gonna do, I think we should have right now a GUI at least. Now we gotta basically add some few messages and basically handle those. Yeah. So the messages that we're gonna add is, okay, so it's already finished. There we go. As you can see right now, we got like the scrollable container with the messages, and here ask anything, but currently it's grayed out because we haven't handled the messages updates yet, like the state updates. So how are we gonna do this? We're gonna say message like prompt changed, and it's gonna give us a string. And what's next? And we're also gonna say prompt submitted, I guess. Fine. And I think that's it for now, at least. Okay. And here we're gonna come to text input, and we're gonna say on change or on input. And what we're gonna basically use is message on, like, no, prompt changed. Yeah. And there we go. Now, why this doesn't work? Oh yeah, this should be an in on my bad. And there you go. Next up, we got on submit, and on submit, we're gonna go with message prompt submitted. And yeah, that's cool. All right. So now what happens when prompt changed and when prompt submitted? We're gonna come to this update function, and we're gonna do some stuff. So we're gonna match on the message. Let's go, and we're gonna show add remaining patterns, and here is the new prompt. And what we could too simply do, we could either say, so like the basic idea is you would basically say self.prompt is equal to the new prompt, and then you would basically say self.prompt.clear. But this kind of like, you know, spends one more allocation for no reason. So what you could do instead, you could just say self.prompt is equal to std memtake and mutable self.prompt. Or actually, sorry, wait. I think mutable prompt, no? Wait, what I'm doing? Mutable prompt. Yeah, I think probably mutable prompt. Let's see. Does that make sense? Yeah, I think so. And finally, task none. Hello, overdue RG. Welcome to live stream. How's it going? Oh, great. Actually, I don't know what I was doing here. This is not exactly how it works. Kind of tripping. Yeah, I'm not sure what I was doing. Wait a second. Let's ask the AI really quickly. Let's ask Gemini, to be honest. Let's just see what it's gonna say anyways. So I guess it's correct, right? Yeah, I think it's correct, probably. It just kind of like glitched there. Anyways, fine. Next up, we got the prompt submitted. Now here where we're going to use that task, either stream for regular streams, or in our case, we're going to use even a more interesting one called SIP. Now, I don't really remember how SIP is actually, like how it works. And in fact, can we find some example though? That would be cool. There's even straw other than zipper. So a straw is basically a zipper that can fail. So it basically could return a result. And honestly, I think maybe here we even need a straw, possibly. But anyways. Okay, so you just return something that implements a zipper file, progress. And in fact, let's add another dependency called zipper. And let's go. And now how are we going to use this? So I guess let's just say another function possibly. Or should we just do it inline? Honestly, let's just do it inline. Fine. So zipper, zip, it takes a zipper. So let's create a zipper, and how you do it is by basically saying zipper like this. And then it takes in a callback, a mutable sender. So it gives you like the sender, the channel sender that you're gonna send the progress into. And what the heck is going on here? Wait a second. Honestly, this is gonna trip me off. Maybe. Yeah, this is definitely gonna trip me out. So let's just make it into its own function. Fine. So let's just, I guess, comment this out for a second, and let's say here, I guess, I don't know, send prompt, or like stream prompt, zip prompt. I don't know. Next up, what we're gonna do? I think, in fact, we don't even need self. We just need probably like an agent and stuff, but we'll see about that. Other than that, what it's gonna really return here, it's gonna implement zipper. And it's gonna basically return at the end of it all. I'm not sure what it's gonna return. For now, let's just go with nothing. And the progress would be, I mean, I think probably string or message. Nah, string. Let's just go with string for now. Let's see what's gonna happen there. Okay. And you just add that plus thing apparently. Okay, fine. Whichever floats your boat. And then finally we say zipper mutable sender async move. Zipper mutable sender async move. And let's go. Now what we're gonna do, we're gonna basically take in the agent. So here we're gonna need like the agent. So a clone agent completion model, right? Well, and what we're gonna do next is let stream is equal to agent dot chat prompt or stream chat, yeah. And then here we're just gonna give it the prompt, which is basically a string, so prompt string. And finally, we're also gonna need like a copy of the messages history. So Vic message, well, obviously rig message actually. Is Rust optimal for this? It's pretty much the best, yeah. Stream chat prompt. Now, obviously, it's not like the fastest, like to implement, you know, as a developer, but it's like the most type safe, most thread safe, and all of that cool stuff. And also, async is pretty good actually if you know what you're doing. It's just that I'm not very advanced in async either, so I'm learning as I go too, and trying to, you know, teach what I'm learning too. Other than that, let's also include the messages here, and there you go. So now that we got the stream, we're gonna basically send those messages in the sender here. And how are we gonna do that? Well, while let okay sum, I think, message is equal to our what this would be, I guess token or something, I don't know, we'll see, is equal to stream dot, so we could either say dot next and then handle the result of each item separately, or we could just straight up say try next, and then if any of it fails, like the whole thing would fail, too simply. And yeah, there you go. Make stream mutable, sure. Hello, Dilshad Sadov 7. Welcome to the live stream. Alrighty, so try next. What's up? Honestly, let's see what's going. Yeah, actually, let's make sure to like, you know, in-wrap this or something. Await in-wrap, and we don't really need OK anymore. Let's just say some token. And now we basically get a stream item, multi-turn stream item. So streaming completion response. Let's just call it item, fine. And then we could just pretty much just send it to the sender. So sender.send item. And yeah, honestly, let's change this to a multi-stream item. Why not? Why not C++? Oh boy. I don't even mention C++ when it comes to like async and what is it called? Multi-threading. Yeah, it just sucks. Like the best you could go with C++ for async is it's like a library that I actually covered in this YouTube, like in this channel, which is called, I actually forgot what it's called. Wait. ASIO, yeah. C++ ASIO. And the best you could go is like C++ 22 coroutines. In fact, I probably would find my video in the search possibly. There you go. So if you want to see how C++ asynchronous stuff at least work, then you could go with these videos, but yeah. Anyways, let's just go back into business. Like if you really wanna, you know, like appreciate the Rust borrow checker and like safety, you definitely should try to like at least one time in your life to make like an asynchronous multi-threaded program in C++, Zig, or any other low-level language. But yeah. And here we're just gonna await. And yeah. So what's going on here exactly? Yeah, cool. And I think that's probably it, yeah. Anything else? And finally, you return the output. Okay. So for the output, what are we gonna return though? I mean, let me see what's going on here in in the streaming docs. I mean, at the end of it, you're gonna take like final usage pretty much. So that's something. So I guess we could go with that. Why not? Yeah. Streamed assistant content final usage. Forgive me, I'm kind of noobie. I mean, we're all noobs here, so we're all here to learn pretty much. So I think for that we can go, I guess. Nah, wait. Streamed assistant content. Streamed. Why not Zig versus OCaml? OCaml. I've never tried OCaml before, but I think Rust probably is inspired from OCaml, so I guess I would probably enjoy OCaml too. It's kind of like functional from what I think I know. But yeah, that's all I could say about it, really. I haven't tried it. But if it wasn't for Rust or Zig, then OCaml, like, I think OCaml is probably like C# and Rust mix to some degree, probably, but I don't know. Oh boy, what the heck is going on here? I guess, you know what, let's just do this and let's see how we're gonna, do this first. I guess. Fine. So basically what I want is that, I mean, do we really need a zipper here? I mean, let's actually ask the AI and see. Why not? What do you think about the zipper? Looks like you're trying to bridge the gap between rig stream capabilities and ice state management. Receive tokens from the stream. And stream. Okay, so we could just make a message. Oh yeah. In fact, we should do that, I guess. Logic to convert the stream into a series of messages. What? Oh boy. What the? Infold agent.stream chat. Okay, I didn't know about this one. By the way, can you in future add time zone to your posts for upcoming streams? Morocco and India are different time zones. Sure. I mean, any time I say is just like, what is it? Like Morocco time, yeah. Rig agents often hold into client configurations that are cheap to clone. No, the agent is easily clonable. The AI just doesn't know about that. Your fold approach in view is functional but might become a performance bottleneck. Okay. So here we're gonna get like token received. Or token streamed, fine. And then stream finished. There you go. And then what we could do is we could, where is it? Here we could go with the message. Oh, in fact, no. Let's grab this. Oh wait, how that would work? I mean, token streamed, stream finished. I mean, I guess what we could do for now is basically just send in the message, and then here we would basically send in message prompt submit, prompt changed, isn't it? No, token streamed. Then we give it the item, and then at the end of the day we just return message stream finished. Oh, that seems to actually work. Huh. Well, that's pretty interesting. Remove this mutable. And make sure, wait, what the heck? Why is it asking variable does not need to be mutable? That's a lie. Why? That's very strange. Yeah, I'm not sure why it's asking for me to remove that mutable thing from there. Oh, use of moved value stream. Has type which does not implement the copy trait. That's strange. Oh, should I await it for? Oh yeah, my bad. My bad. I should await it first. And then just say try next in the, okay, so that's how it works. Alrighty, cool, lovely. So now we got this zip prompt function, which just for every token it sends token streamed, and finally it says stream finished. Now what we're gonna do is we're gonna actually like incomment this. Whoops. Well, I guess fine. Let's do it manually then. And not prompt submitted. Wait, what the heck? Well, actually, yeah. Yeah. Wait a sec. No, my bad. So I see now what's wrong with this. Yeah, I see what's wrong with this. So prompt change. In prompt change, what I really want to do here is just say self.prompt is equal to prompt. That's simply it, because it just got changed. But here in prompt submitted, where I want to clear the thing, I could do that little trick where I say let prompt is equal to std memtake mutable self.prompt. Okay, so that's what I was talking about. I just kind of, you know, got it wrong there. Anyways, now let's go with task zip, and let's give it the zipper, which basically say zip prompt, and then here we give it the agent, which is self.agent.clone, and the prompt, which is prompt, and the messages, which is self.messages.clone. And this function takes 3 parameters for whichever reason. It takes 3 parameters, huh? I mean, let me do one little thing, I guess, here. Let's give it that, and let's give it my code. And let's see. So sip prompt. Okay, so the progress mapper is message token streamed. And then here message stream finished. Ah, right. I see what's going on here. I see. So here we're supposed to pass in the token streamed. And then here we're supposed to say stream finished. Right? And then here instead of message, what we're supposed to do. Okay, where's that other self-sip prompt? Write the whole file. And let's see what it's doing. I mean, I could just use a regular stream, but Zipper is quite nice if I could get it to work. I forgot how to use it, so. Hello, Adam Rushford. Welcome to the live stream. So where's the zip prompt? There we go. So what they're doing here, they're just saying full response. Oh, well, I see what's up, but no. Okay, so just saying string and calling it a day. Keyword async. Yeah, you know what? I think let's just go with this. Fine. Or isn't it? String. Actually, okay, let's just grab this and let's put it here. And for the final result, I'm just gonna go with nothing for now. Okay. And here, just gonna give it, like, send it the item and call it a day. And there we go. Can we do that? Expected found. Let's see. So zip prompt. But what did it change here? What the heck? Bruh. Nah, didn't fix it. It didn't fix it. Oh, actually, oh, wait. It's actually the opposite. So like you give it the output, then I guess the oh, right. So you see the AI didn't really understand what the heck is going on here. Other than that, what else? Zipper, fancy composition. Well, anyways. So yeah, that's how it works. Next up, stream finished. Gotcha. could just do this. All right, so I think we're good. Should add C# and Rust scripting, maybe even just convert it to C++. What do you mean? Okay, I think we're good here. So now just add the other messages and like handle them. Token streamed. So here we got the item, and then obviously also stream finished. So for now, just return task none. And message stream finished and task none. Now actually I'm gonna add one thing, which is like, are we generating or not? So we could say maybe is streaming boolean, and then basically in the view we could use that, but we'll see. So here we could say is streaming is equal to false, so like we're done. And then here in token streamed, I guess we could match on the item. So how are we gonna handle this? Let's see. Final response. So this is the one that gives us back the statistics, right? The usage. No? I mean, I don't really care about this one. Yeah. Don't really care about that one. So I think I'll just return, I guess, maybe. I'm not sure how I'll handle this, to be honest. Okay, let's see what the AI would say. Match item, non-exhaustive, non-covered. Really? Is there any other items here? No. So I'm not sure why it's asking about that. So I don't really need the final response, I just need the streaming stuff. And stream assistant item and user item. All right, let's just see. Wait, Google Gemini. And there we go. So when a prompt gets submitted, we take in the prompt text, then we push a user message to history with the current prompt text. And then we add an empty assistant message to the history. And that's where we're going to stream the text. Yeah. Okay, so when we say prompt submitted, we say self.messages.push. Push what? Push a message. User assistant. Well, let's just go with user, I guess, right? Well, obviously rig message user. And next up, what we got? Or is there like some other function here by any chance? Not really. I don't think so. Like the content would be one or many user content. Can I just give it the prompt? I'll clone. .intro possibly. Yep, apparently I can. So maybe just prompt.intro and we call it day. There you go. Cool. Actually, not really. How about .clone here? Nope. Actually, it should be user content, yeah. Yep, my bad. Let's say prompt. and prompt. And expected. Can we see the into now? Bro, what? Let's try this, fine. I'm not sure how that one or many is being made. That doesn't seem like it works. Yeah, no. Okay, so let's try to maybe make that one or many or whichever. Yeah, and we just say one, I guess. And then we could give it like some user content, text, and then we give it the prompt. Expected. Wait, what? So we gotta still say, I guess maybe rig message text, or isn't it? Wait, what this needs? User content text. Bro, what? No, text. Okay, so message text. Rig completion text. Message text. And then why this weekend cannot find function, huh? Oh. User content. And text. And now what? What this takes? It takes again some, what the heck? No way. Bro, I'm super confused right now. No, what? Oh, so like text is just a string. Bro. Where this actually exists, it's probably in message. Okay. Rig completion. Ah, there you go. Or no. I guess we just like construct the, okay. Is that it? Okay. That's a mouthful. But I guess it works for now. And then we basically push also an assistant message. I'm pretty sure there should be like an easier way. Maybe I haven't found it yet. Like user content. I mean, there is this text though. Oh, is that what I'm supposed to use? I mean, okay, hold on a second. Thank you, overdue. Okay, so let's see what we gotta do here. Okay, let's try text and then prompt. Alright, that's way better. Look at that. Look at that. That's way better. Other than that, what if we just say into though, and now? Would that work too? Not really. Doesn't seem to work. Okay, fine. Now, anyways, so let's go to the next thing, which is the assistant message. And add the missing field ID. I'm not sure what the ID is about. ID none. And then we just start empty here. What is assistant message ID? And then self.isStream is equal to true, and then send the history preceding these new messages to the agent. Or send the whole list depending on how you want Rick to handle the latest. Usually send the previous history and the new prompt separately. I see. I mean, we could like just clone the history beforehand. Why bother with this? Yeah, I don't think it's talking about what I'm asking, but anyways, whatever. Alright, so what we're gonna do, we're gonna make sure to clone the history before we add any messages, I think. So self.messages.clone. Can we do that? Cool. And let's just go with the history. Right, and here the prompt, what's up? Ah, I see. So I guess I'll just clone this or just give it a reference. Can we give it a reference? Yes, we can. Next step, what else? Yeah, I think we're good now. Now, finally, the token streamed. And for the token streamed, apparently we could do something like this. I think, you know what, let me just copy this, really. It's just some stuff. Okay, so, but no, I don't want it that way though. I want to keep this matches, really. Yeah, fine, whatever, anyways. So what it's doing here, if like token streamed, if multi-assistant content, text chunk is equal to item. Find the last. I mean, yeah, obviously we're not gonna get, we're only gonna get like assistant content streamed in. So honestly, that first part it's completely valid. So like we could just say if let multi-turn stream item stream assistant item is equal to item, I guess, and just remove this. Next up, we got find the last message, which we know is the assistant placeholder. Yeah, that's valid actually. If let sum, yeah, that's definitely valid. So I guess, can we copy that? So if let's sum rig message assistant content, I mean, honestly, we could just say in wrap here because we know for sure the last one would be that way. So we're good. Yeah, we could just say last, I think. But no, we still need to like, yeah, you know what? Let's just go with this, fine, whichever. Okay, what's next? So now if let's sum text content the itermute.next existing text, well, we should do a similar thing for one or many. We should just grab the last element again and push a string to it. But let's just copy this. so if let some assistant content text existing text content.error mute, can we just say last here by any chance? Last mute? No? Wait, what? Expected assistant content found option. Huh. What if we say in wrap here? Or wait, what? Oh, I think we don't need option here for some reason. Yeah, I mean it's a one or many, so that makes sense. So it would never be empty. Okay, and the existing text.text.push_stir text chunk.text. Where the heck it's getting the text chunk from? I think probably from here, maybe, or something. Yeah, where's getting that? Yeah, it's getting it from here apparently. But we're apparently not using that. How? I see. So you know what? I'm just gonna match on the item. And let's see what we got here. Add the remaining patterns. So either text tool call blah blah blah. Right now we're not gonna bother with the other stuff for now. So just gonna say nothing. And then this gonna happen in the text, and this would give you the text.text, and let's go. All right, that was insane. What else? So no need for mutable there. And finally, what's going on? Let's add that streaming false by default. And are we setting self.streaming or not? So let's just say self.isStreaming is equal to true. And are we setting streaming to false then? Yes, we are. We're doing it here. So now in the view, we're gonna make sure that you can't like submit a new message while it's currently doing some other message, because what would happen is that you would be starting to send like interleaved words or tokens from both messages into the LLM, which is not exactly what you want probably. I'm not sure if that's the case, but anyways. So what are we gonna do now? So where's the box, the input box? Here we go, text input. And what are we gonna do? So that's basically the prompt input is equal to this, and I guess maybe if not self is streaming, then textbook input dot on input. So like prompt input is equal to basically that, like prompt input dot on input. Yeah. Message, and let's make it mutable. So we basically add that prompt changed. I'm not sure if there's like a better way to do this. Is there like an enabled or disabled or something like that? I don't really see it. But anyways, that should work anyway. And finally, what we're gonna do is self is, I mean, in fact, let's also add the same thing with this. Actually, you know what? It should always be on input, but you can't say on submit. Yeah. So let's just add this here. And let's add this here. And yeah, there we go. So if not streaming, then we add the submit and we're good to go. So can we try to run this now and see if it works? I have no clue. We'll see. Hello. Okay, so it works. Can you write a Rust program? And there we go, it works. And notice that more. And notice now I can't really submit while it's streaming, as you can see here. So that's pretty cool. And obviously it's also could scroll. Though it would be cool if I can manage to like scroll it automatically. And obviously we should also add markdown, because right now, as you can see, the markdown is not great. But yeah, okay, so I'm just gonna take a little 5-minute break or even less, and I'm gonna come back. Okay, back. Alrighty, so I think we'll add markdown right now. Hey, what's up? I mean, okay, I guess. How are we gonna add markdown? Good question. Let's see. So we're gonna basically parse markdown every time we change the view, to keep it very simple, I think. Probably. There's quite a lot of few things here. Alright. Yeah, there's a lot going on, bruh. Yeah, I'm not even sure where do we start. So this is basically like the user bubble, the user message bubble, and this is the assistant usage bubble, like a assistant message bubble, yeah. So let's decouple this a bit. So this is like assistant message, and it basically it gives back also an item message, and it's basically a rig message assistant. So we're just gonna do this like this, yeah, or isn't it? Yeah. And then here you give it like the content, which is basically one or many. Assistant content, I think. Really? That's strange. I mean, it works now. That was weird. And let's just say .intro here. And that's the assistant message. So now, instead of doing this, I think we could just say, well, not here, actually here. Wait, what? Yeah. So let's just remove this part, I think. And let's say self.assistant. Wait. Oh. And then let's give it the content. And there we go. Or shall I say assistant message view, to be exact. And in fact, let me just put it here, why not? Okay, so now let's add the other ones too. So next up we got the user message view. So let's grab this. And let's make another function really quickly here. And it would be similar to this. Hello, unknown 9500. Bro, I'm new getting into programming, kind of confused from where to start. Few tech stacks I could focus on, got me a bit. What's your background and what's your goals? Okay. Alright, so instead of assistant here, we're going to say user message view. And then content, instead of assistant content, we're going to go with user content. And finally, we're going to return an element here. And here we're going to say the intro. And let's go. And yeah, that seems to work. So now we could just say self assistant, not assistant, user message view content. And let's go. And what is this? This is basically the message list view. Yeah. Message list view. Okay, let's make it. Let's just actually copy this. And let's just grab this whole thing. And you're just gonna take in like messages. Well, it's gonna be like rig message, I think. Well, obviously vector rig message. I mean, in our case, we just need like an iterator though. where the item is rig message, and we're good to go. And finally here we got the element. Well, just consider intro, and we're good to go. Now what's up here? Actually, wait, no, let's say this, I guess. No? Wait, what? I'm doing my bachelor's in CSE, and I've started with Python and JavaScript. Just want to get into the industry, start off maybe as an SDE. What SDE stands for? Oh yeah, software development engineer. In CSE, computer science engineering. I'm doing, so what are you interested in? Are you interested in a particular like computer science domain, like AI or data science or something in particular, like web or game development or engine development or graphics? AI is just best just to learn in the beginning. It's just the fastest route, reliable, simple guidance. Once you get a feel for it, keep going, abandon it until you're somewhat good at something, rinse and repeat the process. Yeah, that's good. Yeah, and AI and ML. AI and ML. I mean, AI and ML, you would probably better off just go with Python. But the future would definitely be in the hands of Rust. Because like the ecosystem is growing very rapidly in Rust. And it's just a much more robust language. But if you just want to get hired, you know, and just want to get like into the industry and like find tutorials and learn in general, just go with Python. Just go with Python, AI, and ML pretty much. Don't bother with Rust for now. Later on, once you're done with Python and you feel very comfortable with your thing, you could upgrade to Rust, you know, like as an added bonus. But yeah, so like in Rust, you have Candle, for example, if you want to create like your own ML models and stuff. So this is kind of like, you know, PyTorch. So it's a minimalist ML framework for Rust. I want to try this honestly at some point in a stream. That would be very cool. I don't have that much experience in ML. But would be very cool. Now, in our case, we're not obviously like, you know, making an AI runtime. We're just using an API. So we're using rig. But yeah. All right, let's go back to business. So where we were. Yeah, I was here. Okay, so this gives me item rig message, which is correct. Does it like need a lifetime here for any reason? By any chance? Yeah, okay. So you just need the lifetime there and you're good to go. And what we could do next is we could just, I mean, we could just grab self. But I guess no need for now, maybe. So right now what we say is just like self messages view, and you say self.messages.iter, and you're good to go. And here's your messages. Perfect, perfect, perfect. And that's the prompt view. Yeah. And finally we got the prompt view. and it would also like return an element, and you have to give it like the prompt stir. There you go. And here, can we just do this for now? How about that? And also let's just give back the prompt input dot intro, and there you go. So that works. Oh, I also need to know if it's streaming or not. So is streaming Boolean, I think, or too simply just Boolean. Or too simply is enabled. Let's call it is enabled, fine. And now in our view, what we could do is to simply, messages, cool, and let's just grab the prompt now. So prompt view, and you just give it like the prompt, which is self.prompt, right? Yeah. And this enabled is basically self is like not self is streaming. And let's go. All right, so right now we have the same thing we had before, just a bit more organized, because it was getting out of hand. But yeah. Now we could add some padding to the whole thing. And where are we going to do that? Well, okay, so what we're going to do now is the view. Okay, so here we can say dot padding, and we could like add, let's say 8 pixels of padding. And now you're going to notice the whole UI is kind of insetted into like 8 pixels of padding. Also, this text box could possibly make use of more padding, just for it to be conformable, possibly. Where are we going to do that? Prompt view. Text stack is basically just like the language that you're using, the libraries, etc. Nothing crazy. But anyways, prompt input dot padding, and can we just say maybe 8 here? Let's see how that looks like. How about 16? Where's that? Oh, there you go. So how about 16? All right, that's a bit too much, maybe. Yeah, a bit too much, I think. Let's go with 12. How about that? Yeah, 12 seems good, actually. Fine. Other than that, what else we're gonna do is we're gonna make sure that the bubbles actually have a background. So how are we gonna do that? So basically in the assistant image view, so instead of just a column, yeah, we're gonna make this into an actual container. import. And then we could add some padding too simply, like, I don't know, maybe 16. How about that? Or like 12, fine. And we could do exactly the same thing for this one. Speaking of which, maybe we should create like a bubble, message bubble. Yeah. And it would return an element message. Whoops. And let's see, so it would basically be this part of the code. And I think, should we just like pass in this as an argument, or should we use this callback? Con.push. I guess for now we could probably just go with this instead. Fine. So like content is this. Create the lifetime parameter. The theme and the render. Oh boy, can we actually avoid that? Oh, well, yeah, we can. Yeah, we could just say content this. And yeah, we could just remove this now. And yeah, we're good. I think message bubble. And now instead of like container, new, etc., we could just say message bubble. And instead of padding, let's remove that. And we don't even need like into right here, I think. And we're good. Expected element found column. Oh. Oh yeah, I see. I mean, we could say, I guess, maybe impl into element. How about that? And let's try to add a lifetime here. And that works. Great. So now we're going to do a similar thing here. So user message view. Yeah, there you go. I think we're good now, but let's probably add some sort of a style here. So what are we gonna use for the style? I mean, I guess we could go with container. And then there's secondary bordered box, background, danger, dark, draw background, primary rounded box. Let's try maybe bordered box for now. See how that looks like. And look at that. Okay, so now let's make sure to add some spacing though. Where's the spacing? In the message view. I'm gonna say dot spacing is equal to, well, I guess maybe 8. How about that? And let's go. Write a Rust program. And look at that. That's pretty sick. That's pretty lovely. Can we even like align this possibly? Like basically the user. Yeah, we probably, or can we? Wait. I don't think actually. I don't think you could like align each one separately. But yeah. Can we align? Like vertically align or horizontally? Can we align user messages differently from what is it called again? Assistant messages. I don't think that would work though. Oh, I see what the heck it's doing. I see. So let's go to the user message view. And we're gonna go with dot align x. Wait, I guess this or what? No. What this takes? Takes alignment. Wait, no. Alignment. Horizontal. Oh, okay, cool. And the user message view gotta be on. Is this supposed to be on the left or on the right? I think the left. I mean right, probably. So let's go with that. And for the other one, for the assistant message view, we're gonna go on the left. But this would still not work as expected, I guess. But let's just try this. Yeah, you know why? Because the main container of the message bubble should expand to take the whole space. So how are we gonna do that? By basically saying width, length, fill. And I think right now it would work as expected. Oh, but it should shrink. It should make sure to shrink the individual messages though. Yeah, let's do that. So the message bubble, can we just do shrink like width, length? Shrink, how about that? Hey, no, that doesn't work. Huh, let's see. Oh, I mean, because the style is applied into the container itself. All right, gotcha, bro. Gotcha. So you know what we can do, though? We could create another container, right? So inside of this, that doesn't have any background and doesn't really have any extra stuff. It's just there, pretty much. Actually, it should have the style, yeah. That one is the one that should have the style. And also probably the padding. The only thing for the external container, the only thing it should do is it just should like occupy the whole space. That's all. I think that's probably the case, yeah. Still doesn't work, but we're probably getting closer. So right now, since we have the inner one, we could probably take in alignment. So how are we gonna do that? Well, we could take in, I guess, align, alignment, horizontal. And then we could pass in the alignment here. So in fact, we could remove this from here now and remove this, and probably even like remove this too. Yeah. And now just make sure to add the alignment. So we're gonna go with the alignment horizontal, and for the user message view, it's gonna be on the right. And for this message bubble here, it's going to be on the left. Is that correct? That doesn't seem like it is correct. Why? Oh, we're not using the align here yet. Oh, but I can't wait. How do you align? Oh, there you go. Align X. Let's just call it align X. Fine. And let's go. How about now? What the heck, bro? Oh, so actually probably the align X should really go here instead. Yeah, I think so. There you go. It works. It works. Hey, hello, how can I assist you today? Can you write a Rust program? And look at that beauty. I wonder if I could change like the color of the bubbles. But anyways, that works. So right now we need to work on like the markdown rendering. So how are we gonna work on the markdown rendering? Very good question. Well, I guess that's gonna be interesting. So here where we have like the content, so we'll have to figure it out. Let's see. So here we got like the text column dot push iced widget text. Okay, so we're currently wait. How do you even like do the markdown thing anyways? You know what? I'm gonna do something interesting. I'm gonna go to Gemini, paste my code here, and I'm gonna go to the examples here and look for the markdown thing. And grab the example here. How can I integrate markdown? Here is an example. Here is the official example from my iced version. You need to store the parsed markdown content. Arrive in chunks will update the content whenever a token is streamed. So store the parsed versions of messages to avoid reparsing everything every frame. So we got just like markdown cache, vec markdown content. I mean, fine. We're gonna import that widget. Update the update logic. Update the update logic. When a new token arrives, you need to reparse the last message text into the cache. What? Update the markdown content for the last message. So where we're doing that push stir, are we even doing that? Yeah, we're doing that here. So if let's some content self.markdown cache.last mutable md content. Oh wait, what? So it's trying to get the last item, just like here we did, like we did here. But wait, who's like adding content then? Like who's adding the markdown cache? I guess we'll find out. Ensure you also, there you go. Ensure you also push a new markdown content new to markdown cache inside message prompt submitted when you push the empty assistant message. Gotcha. So markdown content new in here, right? So self.markdown cache.push markdown content new. Okay, so that works, I guess. Update the view logic. Replace your assistant message view with the markdown renderer. Oh, what does it like remove that whole thing? What the heck? Really? So you're telling me we're gonna replace this whole thing? Bro. That would be cool. So assistant message view, instead of this, from what I understood, we could just like comment this out and just do this. Yeah, because we don't have text anymore, like individual text elements. Anyways, so markdown view md content.items. So the md content is markdown content. Now the markdown view, well, there is a few problems here. First problem is that the markdown view needs to grab like a message for when a link is being pressed. And what else? What else? Yeah, so I guess let's just add it right now. Markdown link pressed. And this one, this is not how it's being done. So here we're just going to say map to a markdown link pressed. Message markdown link pressed. And that would fix the first problem. Hopefully. Well. Oh, actually, wait. It needs the URI. So like the markdown URI. There you go. Now that should work. So that's the first problem. The second problem is the settings. It doesn't have the default. You only have with style. And I'm not sure how would that work. Can I just like feed this whole thing? It's too big, but could be enough though. Wait. Okay, so there's something else there. That's cool. Oh, we gotta do it for both the user message and... Okay. Although I'm not really sure if I want to do it for the user message. I mean, you know, let's just do it anyways, I guess, fine. Bro, come on. Settings doesn't have default. It only have with style. In fact, how did the example like use that? Wait. Let me see. So like we have an image. Like for example, code block. Who's calling that, for example? I don't see anybody calling that. Weird. Well, that's confusing. Like, I don't get it. Who's creating that settings? Come on. With style, markdown style from palette. Okay. All right, fine. Let's just copy this part. And let's go to the view. Well, where is that? There you go. Theme.palette, but where is the theme? Iced theme. There you go. Okay, next up. Now we're just passing the settings here. Now the element should go with the MD content, I think. And let's go. So we just create the style, create the settings, and we're good to go. Alrighty. So that's pretty much it, I think. MD content. In fact, since we've done it this way, we could like add all of this stuff into the message bubble itself. Yeah. Yeah. So let's change a few things here. Let's add that, and let's add the theme. And here we're just gonna grab the MD content instead of the content. And then we're just gonna say markdown view. And let's go. Perfection. So now what we're gonna do next is, right now we're just gonna, create like the markdown things, like the MD content, the items. So basically MD content, the items. Or isn't it? Markdown content. Well, I guess we could just go with MD content, yeah. And yeah, that's all, I think. Finally, we just like give it the theme. And that's all, right? Same thing here. We just have the rights. And pretty much we should also add the theme here. And let's add the lifetime. And we're good to go. So we gotta basically build up the MD content probably somehow and do other stuff, but yeah. But let me allow it to continue. Markdown cache. I probably haven't done that yet, so let's add that. Just say vic new. Let's go. Next up, we pass the whole app to message view, so you can access the cache. Really? Use the current theme ICE provides, or you can pick one. Okay. Well, then instead of doing that crap, maybe you could just, or fine, whichever, anyways. In fact, what if we just like use this directly, call it a day? Yeah, let's try to change that. See if that would work out of the box. Prompt view. Do we have, whoops. Do we have prompt view here? I don't think. Nah, that doesn't change. So just like this part only. But in fact, nothing to change here except for the message view, I guess. Or isn't it? Yeah, it's only the messages view anyway, so fine. Let's see. So use the current theme. I mean, just go with default, bro. Come on. Preference mode. What? That's strange. But fine, let's go with mode dark for now. We need some way to detect if it's dark, or I'm not sure how. But yeah. Anyway, so self.messages.iter.enumerate fold. Column new spacing 12, column I message. Used get the corresponding parsed markdown from our cache. MD content self.markdown cache. Okay, match the message. If it's a user message, then MD content theme. Okay, that's cool. That's sick. But who's building? Is that it? Really? Now for this markdown link pressed, we want to basically open it in the browser or whichever. So what we gotta do? We gotta add open. So there is a crate called open, which would allow you to open any link. So here, markdown link pressed, when we get some URI, we could pass it to open. Open that, and you just pass in the URI. Can we just say maybe in wrap? And finally, task none. And let's go. What else? Here let's just say self.messageView anyways, fine. Whatever. And we're good. Would that be enough? I wonder. Please tell me that's enough. Hey. Oops. Well, actually, yeah, it does work at least here, but here no. Well, guess we'll have to find out why. Can you write a Rust, or you know what? Can you make a table? of whichever. Well, not SQL table, god. But look at that, like code right now actually works. I meant markdown table. Nah, I didn't do it right. It's doing it using code. No, not markdown code. Just spit markdown table. I suck at prompt engineering, bro. Yeah, it's lost. Create a list comparing Rust and C++. Not list, table. Write a table. There you go. Okay, so now it works. Look at that. So now markdown works, but we have to fix this user thing. Yeah. Okay, so right now let's see what's the problem with that part. This works, but the user message bubble is empty for some reason. We're probably just like, you know, not adding something there. I would guess probably when we add the markdown, we should probably parse it directly. Yeah, I would guess so. So like here, we're currently just adding this, but we should actually just parse the text. Yeah, probably. But let's just see what the AI would say anyways, so we can not waste time. Before you clear or use the temporary prompt variable to populate the cache. Okay, but I like... Okay, cool. There you go. So yeah, you just parse the prompt directly here instead of like pushing an empty one. Let's go. How about now? Hey. And now it actually works. Write a Rust program. Look at that. Oh, it actually already supports the highlighter. What the heck? So yeah, you just like add this highlighter feature and it just works. That's sick. Does Phi 3 model support images? Anyways, can you spit a clickable link? Bro, it just get lost very quickly. The local models aren't that, you know, powerful. What are the top 10 links? There you go. And look at that. And there you go. We have made it. We have done it. All right. We're apparently not using Tokyo directly, I guess. Seems like. Or maybe we do, I'm not sure. I mean, if we remove that part. If it tries to recompile, yeah, no. So we don't need Tokyo. ICE already includes Tokyo apparently. And we're still not using tracing. To be honest with you, I don't even need tracing at this point, I think. Yeah. And I'm not sure why I'm not using anyhow, though I'll probably use it at some point, possibly. So we could just remove tracing for now, fine. And you know what, fine, let's just remove anyhow too. So right now, as you can see, we just need ice to record zipper and open. And you get this cool thing. So yeah, that's lovely. So what do we need next? Yeah, I want to try some images. I wonder if that would work. I mean, we're not handling images yet, though. Maybe it's handled. Look at that. Llama is using like 3.7 gigabyte of GPU memory. And yeah. Okay, so let's see. Does Phi 3 Llama support images? Yeah. Yeah, it's text only. Actually, wait. I mean, no. I mean, it's spitting like Markdown. Hold on a second. Wait. If I give it some like image URL, I'm not sure. Can we find some image URL? I don't know. Is this an image? Bruh. I just want to find any image. Come on. Fine. And yeah, whichever. Anyways. Copy the image address. Can you display this in Markdown? Whoops. Wait. Can you display? How do I tell it to... but it is spitting Markdown, so it should work. Can you make a prompt for Phi 3 to push it into including some Markdown image? Act as a technical guide, explain how a solar panel works. I mean, you know what? Let's try it. It said solar panel, then it didn't show anything. Is this link even like valid? I don't think it's valid. So maybe it's just the link is not valid. So I could just take this, copy the URL, or copy the image URL or something. Yeah, copy image address. Oh my god. Yeah, this kind of suck. Maybe we should give it like some sort of an ID, because it doesn't work that well right now. Yeah. Let's go back here. And And let's just copy this part. And let's slice this URL here instead, because it probably just hallucinated that URL there. And let's try again. Nah. Wait. Why didn't you include that? Bro. Let's try again. Let's try another prompt. Format it as... Yeah, I don't know. I don't know how to make it spit like a markdown image. Make a simple prompt to push it to make markdown image. Whoops, wait. Copy the image address and let's come here and oh, does it actually have access to the web though? Yeah, is there like some way to include that or something? I wonder. Yeah, I guess it's probably doesn't have access to the internet. I think it works now. Okay. Is there something else here that we need to know? Wait, does iced have a feature for networking or like downloading network images? Iced remote image, but I'm not sure how they integrate that even with the what is it called? Yeah, I just hallucinated that. Just hallucinated that. Is there some example here by any chance? Yeah, I don't think so. Or isn't it? Okay, how about we tell it here? Or let's check out iced features really quickly first. Iced features, where's that? Feature flags. There's even SVG, which is interesting actually. Do you see any relevant feature here? Other than that, what we could do is take some thumbnail like this one, copy the location, and tell it to display that instead. And see if it can at least do that. The markdown feature. Can you just make it display this local image instead? No, I meant prompt phi3. That doesn't work either. So I need to figure out how to do this. Enable the image feature, update your message bubble. I didn't notice that one. Really? No way. I think it just hallucinated that. Yeah. That view function only takes these two parameters. Bruh. I wonder if Markdown actually have that. Yeah, I do remember something about images there. Yeah, my bad. Okay, so let's go. I mean, I'm already in it actually. Yeah. All right, so let's just feed it that. You're just straight up hallucinating. Here is the official example. Replace the download image function. Bro, what? Here's the official example of Markdown. How can I integrate image loading into my current program? Okay, so we gotta use view with apparently. Yeah. Okay, you need messages to handle when an image is discovered in the markdown and when the download completes. Oh boy. Okay, so apparently you handled that yourself, essentially. That's cool. That makes sense. Okay, so let's create our custom viewer. And let's use that. So custom viewer. So currently let's just, it won't have anything for now, fine. And let's try to implement this markdown viewer. Is it like maybe markdown viewer? There you go. And what's this generic here? I guess message, yeah, and theme and renderer. And now let's just generate the functions, I guess, or isn't it? Indicate the anonymous lifetime if you need that, whichever. Oh, okay, hold on. For custom viewer. And now let's implement the functions or the members. Alrighty, okay. So the required one is on link click. This is required. Then you also have one for image, one for heading, one for paragraph, one for code block, one for unordered list, or ordered list, quote, rule, table. So that's pretty sick. But for now, we're just gonna go with on link clicked and image potentially. And let's see how that works, I guess. Let's indicate the anonymous lifetime. And what we do for on link clicked, we just return a message markdown link pressed URI. That's pretty simple. Next up here in the image function, we take in settings, the URL, the title. Can we just do this here maybe? The title and the alt. And here you gotta return an element, an iced element. Can we just do this? And no need for theme and renderer. Doesn't match. Okay, no. Go back. So how are we gonna do that then? That's strange. Okay, what if we just keep at least the lifetime maybe? How about that? And the theme and the renderer. Alright, so that works. That works. So now how are we gonna do this? Apparently you just say iced widget image handle.clone images.get oh, it's just a hash map. Gotcha. Do we really want to do it this way? I mean, fine, whichever, anyways. Let's just add this hash map of basically import image state. What is image state? Oh, is it loading or ready? Okay. And finally, like the image handle apparently here, if it's ready. And what else? And here in the actual application, we have the actual hash map itself, not just like a reference. So where's the app? There you go. remove unnecessary prefix, and what we're gonna do next. And let's just add the lifetime here. Lifetime here. And implement lifetime. Wait. Okay, so you do it here. And I guess you don't need it here either now. And let's go. Now you just do this. So if let some image state ready, then equal to self.image.get URL, then we just use the widget image, the iced image widget, and we give it the handle. Else, sensor triggers message image shown when it enters the viewport. Huh. That's cool. Okay, so a sensor widget can generate messages when its contents are shown, hidden, or resized. You can even notify you with anticipation at a given distance. That's crazy. So iced widget space, use the built-in widgets or create your own. Space, create some empty space with no size. This is considered the identity widget. Will take no space and do nothing. Okay, I see. So when it is shown, we're gonna send this image shown message. What else it have? Anticipate too, so you could give it some distance. That's cool for UX, yeah. Anyways, what's next? We're gonna need some few messages, which is the image shown, the image downloaded, and the tick instant for some reason. So let's just add those, fine. And we don't need this prefix here and here. And I'm not sure why they included the tick, but we're gonna find out in a second. And some arc image error. Nah, what? Yeah, I'm not sure what it's talking about there. But I guess we'll find out later. So now we implement the custom viewer. Yeah, we have that already at this point. So now the update logic. So let's just copy this and see what's going on there. So the update. So when an image is shown, we check if it's already there. Otherwise, we return task none if it's already there. And then we try to insert the image. URI.clone image state loading. Okay. And then next step, we try to trigger the download. So task perform download the image. And then after it's done, I guess we maybe move the result into message image downloaded URI rest.map error arc new. And then if the image is downloaded and if it's okay, then we just insert that image as a ready image into the images hash map. And we're using the tick for whichever reason here. I'm not sure why. Okay, so let's copy this. Where's the download image thing? Okay, so right now we're going to use view width, and we're going to pass in the custom viewer. Okay, so message bubble. The images and view width. And here we're just going to pass in the viewer, the custom viewer, and we're going to give it the images, isn't it? Converge, and let's go. and we don't need this map thing, and boom. Right, so now we gotta make sure to pass in it here too. And for that, we're just gonna copy this images reference, put it here and here, and provide it here, and provide it here. There you go. Next step, we're gonna find out what is the doloid function. You can copy it from the example. Sick. Okay, so where's the example? Let's see the doloid image function. All right, I'll just grab this. And it has some sort of an error, which is this. Wait, what? Okay. Let's just copy this part. And let's put it down here, I guess. And let's go. So we're gonna import the IO here. I would probably guess the std IO. Could be wrong though, but yeah. And then from Tokyo task, I mean, whichever, anyways. Add image to the dependencies. Okay. And finally, request. So it's including request. Cool. We could probably use this error for this part. I'm not sure, but yeah. Other than that, what else we're gonna do here? We can just right now use that error thing, I guess. So instead of image error, it's basically just error, I think. Though maybe even without an arc, isn't it? Yeah, I mean potentially. So what's the errors that we have now? So let's just make sure to add the images here, default. And image loaded or loaded. What we do when the image get loaded or loaded? So task perform, image shown. Can we just do this? Okay, that's cool. So we triggered the doloid. So this is like an instance now. And what other errors we have? Well, for now, let's say task none. I'm not sure what to do there. Okay, so here we gotta pass in something. So what's that something? Images, okay. Can we do this? And this. In resolved import URL. You could probably get it from request, but we don't care about that right now. So now, what do we do when an image gets downloaded? We insert it. Oh yeah, there you go. Oh, wait. I think maybe I know what's going on here. Potentially. Yeah. So what happens when you got an error? Gotcha. So we're just gonna do nothing for now. And let's go. I'm not sure what that tick now is being used for. Currently it's not being used for anything. But I might be missing something. Now we gotta look for that prompt that we had earlier. That kind of worked. Okay, where's that prompt? I don't know. Give me a prompt that display that push phi3 to use markdown rendering to display this image. Let's grab some nature image really quickly. Wikipedia, please. Where's Wikipedia? Come on. Copy image address and right. Would it work? I don't know. Well, first of all, something is wrong there. And no, it didn't seem to work. Oh, or maybe, yeah, maybe it's just because, I don't know. Let's try again. Yeah, it actually does emit that. And it does say trying to download the image, but then nothing happens after. It says trying to download image, but then nothing shows up. Oh. I mean, I guess we could try fine. Okay, where's the image function? Is it here? Yeah. So like width. And for the width, I guess we could just say for now. I mean, let's say maybe fill. Or we could just say fixed, fine, whichever. That's the width, and let's go with the height too. Now obviously we should actually store the resolution instead, or something. But for now we're good. We're just trying to make this work first. Do I still have the prompt? No. And let's find out. And again, it's still trying to download the image, but nothing happens after. By the way, we're not saying anything in the error branch, so I guess maybe let's check that. Where's the image downloaded? There you go. Okay, failed to download in supported URI. Oh. Okay, where we are creating the request client then? They were doing it here. So you're telling me if I add this user agent that would fix it? Really? Bro. Now it's not great that we're creating a client every single time we download an image. But right now we're just again trying to get this to work first. And what's up? So this could fail now. Let's just unwrap for now, fine. Or replace that with that. And let's try again. Ah man, let's grab that prompt again. Let me actually put that in cache so I could easily like copy it over. And no, it's still problematic. Well, that sucks. Well, that's very strange. Still, URL parse a relative URL without a base. Really? That's weird. Use this prompt. Let's grab this image shown, fine. I'd love to get this to work in this stream, but it doesn't look that great so far. Fine. Or maybe we could just try some other link and see. Let's grab that. Bro, really? Oh, crap. It works. Nice. It works, I think. But our user prompt though is a bit broken for whichever reason. Oh, there you go. There you go. All right. So that works now. Though for whichever reason, it's kind of slow. Could it be because we're not using WGPU? Is that why is that the case? I mean, I think TinySki only uses the CPU though. So let's switch to WGPU and see if that's the problem there really quickly. Because when scrolling, the application really slows down, especially when we added the images. Okay, so right now it works properly. And yeah, right now it's way faster than TinySki. Oh my god, way smoother. Because it's using the GPU. Lovely. Now one last problem that we have here is just the image width and height aren't being respected. But it seems like, I guess maybe the handle itself potentially have the image width and stuff, no? Or you know what, let's just ask it. This works now, for some reason. Later on we could remove like the user agent and the other stuff and see if it still works. So we could identify what was exactly causing the problem. Other than obviously the prompt, I think maybe at some point the agent was like, you know, just saying exactly URL instead of like, you know, treating it as a template for the URL kind of. But anyways, whatever. So what we're gonna do now is just implement better image size handling. Okay, so what we got? Prevent the image from being massive on ultra-wide screens. Keep the chat readable. Really? Why not use the width and the height though? Bro. That's strange. I mean, I know about that one, but Oh, or is it really doing that? Wait. Ready? Oh yeah, it is. Kind of like width, length, fill. Yeah, I see. I see. So I guess we could copy this markdown viewer thing. And let's go ahead and do that. Fine. Oops. Load in the image. And boom, it works now. But for whichever reason, that first image doesn't work here. Actually, it doesn't. You know why? Because here we're using URL like this. So yeah, I'm not sure about using markdown parsing here really for the user. Yeah, that sucks kinda, honestly. Yeah. So you know what I'm gonna do? Maybe. Like, what if we actually do remove that, but like user content text prompt. Or you know what? Let's not bother with that right now. So I think this works at this point, so we're good. Okay, so I guess that was it for this stream. Oh my god. It's been like just 3 hours. Oh god. That's cool. That's pretty sick. So like 400 lines of code almost, though a lot of these lines could probably get removed by using this error or something, but yeah. All right, so that was it guys for this stream. Thank you all for watching and see you in the next one. Goodbye everyone.